Welcome to Chapter 3. Now we will move aggressively beyond foundational hardware into fascinating emerging trends heavily reshaping computer science. The most rapidly discussed field is artificial intelligence. AI is explicitly the grand scientific endeavor to simulate true cognitive reasoning and complex real-time decision-making capabilities using exclusively digital circuits. However, achieving AI fundamentally relies on machine learning. Instead of massive human engineering teams mapping out thousands of static logic rules, ML models autonomously refine their own predictions actively by analyzing heavy, unstructured data pipelines. Once supplied with massive external training sets of organized variables, they quickly run recursive testing phase deployments to naturally adjust internal parameters precisely against complex errors. But machines need natural data natively. Natural language processing acts as a dense algorithmic bridge to accurately organize complex human voice commands directly into strict machine operations, cleanly, seamlessly. Furthermore, massive disruption is occurring visually via immersive experiences. Programmers are moving aggressively past extremely flat visual rendering and injecting dynamic data deeply into interactive, fully 3D spatial configurations. Specifically, virtual reality utterly strips away external visual input, utilizing entirely isolated digital headsets to fully immerse the user safely within intensely realistic digital environmental logic. Augmented reality, however, keeps the user visually anchored entirely. It leverages clever heads-up hardware components to layer incredibly dense digital mapping statistics transparently over normal spatial reality seamlessly. We also map massive software logic physically outside the server. Robotics heavily intertwines cutting-edge computer processing safely into precisely tooled mechanical components, saving extreme human labor aggressively in high-danger industrial factory ecosystems. Current generation robots span dynamically from highly intelligent autonomous tracking drones used heavily in military logic setups to sophisticated multimodal humanoid systems utilizing artificial neural circuits actively. To power massive artificial intelligence parameters correctly requires big data. Globally, computers now aggressively process heavily over 2.5 quintillion massive bytes of variable media interactions per unique day. Traditional SQL crashes completely against this pressure. Professionals define true big data constraints by mapping the 5 versus war. The first is volume, a brutally literal metric measuring the massive physical raw size of overlapping datasets securely. Velocity denotes precisely the hyper-accelerated momentum rate at which this unstructured chaotic info generates massively across global public networks sequentially. Variety represents precisely the complex structural nightmare generated by stacking completely incompatible video feeds closely against messy text logs natively simultaneously. Veracity indicates strict bias and noisy corruption probability. Value defines strictly how lucrative these hidden internal trends are fundamentally when extracted algorithmically securely by global enterprise. Tremendous data generation overlaps closely with the Internet of Things logic loops. The IoT massively networks previously dumb household electronics efficiently with highly robust digital Wi-Fi transmission chips globally. To allow completely varying smart fridges effectively to securely talk to entirely random smart cars simultaneously, engineers dynamically embed extensive Web of Things protocols to normalize software connectivity limits securely. Inside these IoT devices sit incredible advanced smart sensors perfectly calibrating localized inputs. Your phone's accelerometer or active digital gyroscope precisely reads massive environmental context natively continuously. Connecting millions of these active sensors constructs entirely what we actively term smart cities, seamlessly. These networks dynamically trigger vast municipal alarms, accurately tracking precise bridge vulnerabilities, cleanly, automatically. How do developers realistically operate inside these immense storage constraints? Cloud computing totally alleviates internal server needs closely by massively outsourcing data pipelines securely across heavily redundant enterprise networking data centers. Renting out raw digital architecture directly securely defines IaaS, or infrastructure as a service natively. You strictly just rent extreme multi-terabyte drives cleanly without massive initial mechanical hardware purchases. Alternatively, You actively subscribe to platform tools perfectly like hosted Python instances via PaaS natively, or purely consume final browser interfaces completely like Google Docs aggressively via SaaS. Cloud frameworks are strictly centralized logic. Grid computing operates contrarily entirely. It stitches completely randomized physical user laptops dynamically into entirely distributed supercomputers capable flawlessly of cracking ultra-dense mathematical theorems collaboratively. This heavy decentralization actively powers massive blockchain setups seamlessly. Massive global ledgers inherently resist deep hacking corruption exactly by relying inherently on complex multi-node peer algorithmic verifications completely uniformly. In Chapter 3, we observed actively exactly how entirely unbridled AI integrations strongly couple cleanly tightly with immense data environments natively. See you in the next exciting sequence.